Radar system. In general, the radar is an electronic system used to discover the fixed or moving object, and determine their location. The radar could determine the object direction and their height and distance. The radar works efficiently in the night, even in the heavy fog or rain and snow. The capability in the radar makes it important in a lot of fields, which is, for example, the pilot used it land the airplane safe, especially when it's crowded. And also the navigators used it to avoid the dangerous area while they sailing their ship. Each radar device works by send radio waves toward the object, and receive the wave that reflect from it. Each radar device has different shape and size, but all of it is one basic part. And every device is sender to produce radar signals, pneumatic broadcasted inside. The idea of the project is to build a radar system that can detect objects within 5 meters. The project aims on the use of ultrasonic sensor connected to the Arduino UNO. The ultrasonic sensor scans an angle of 180 degrees, using a servo to move it to different position. The software consists of the code of radar applied to microcontroller and code of process. The processing code is a radar screen that reflects the signal received from the sensor by drawing it. Project parts. Arduino UNO. The Arduino UNO is a microcontroller board based on the Atmega 328. It has 14 digital input-output pins, 6 analog inputs, a 16 MHz ceramic resonator, USB connection, a power jack, an ICSP header and a reset button. It contains everything needed to support the microcontroller. In the project we are using Arduino UNO R3 board with DIP Atmega 328P. Servo motor. A servo motor is a rotary actuator that allows for precise control of angular position, velocity and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. It also requires a relatively sophisticated controller, often a dedicated module designed specifically for use with servo motors. Servo motors are not a different class of motor, on the basis of fundamental operating principle, but use a servo mechanism to achieve closed-loop control with a generic open-loop motor. In the project we are using parallax standard servo. Ultrasonic sensor. Ultrasonic sensors work on a principle similar to radar or sonar, which evaluate attributes of a target by interpreting the echoes from radio or sound waves respectively. Ultrasonic sensors generate high-frequency sound waves and evaluate the echo, which is received back by the sensor. Sensors calculate the time interval between sending the signal and receiving the echo, to determine the distance to an object. In the project we are using HCSR04 ultrasonic module distance measuring transducer sensor. Liquid crystal display. The LCD is about crystal screen that has a parallel interface. It has a microcontroller to manipulate at once and control the display. The process of controlling depends on how to add the data that will create a picture of what will appear in the data documents. The liquid crystal could control to position 4-byte or 8-byte from the Arduino, and that will cost you 11 pin for the 8-byte. To add the text on the screen you can do everything by adding the 4-byte. In the project we are using LCM1602YIC serial LCD module. Tamiya universal plate and Tamiya track and wheel set. In the project we are using set of 2 Tamiya universal plate and 1 Tamiya track and wheel set. Parallax mounting bracket kit. In the project we are using parallax mounting bracket kit, which include parallax standard servo, USB 2.0, a male-to-female cable. We use this cable in the project to power the Arduino and to read the outputs and serial COM. Female male and male male jumpers. We used 10 female male jumpers and 5 male male jumpers to connect the all parts in the project. Breadboard. It doesn't matter what size or shape your breadboard is, we used a half-size one. Arduino Integrated Development Environment. The Arduino IDE is a cross-platform application written in Java, and is derived from the IDE for the processing programming language and the wiring projects. It is designed to introduce programming to newcomers unfamiliar with software development. It includes a code editor with features such as syntax highlighting, brace matching, and is also capable of compiling and uploading programs to the board with a single click. A program or code written for Arduino is called a sketch. Arduino programs are written in C or C++. Users only need to define two functions to make a runnable cyclic executive program. Setup function that run once at the start of a program that can initialize settings. Loop function that is called repeatedly until the board powers off. Processing software. Processing is an open-source programming language and integrated development environment. It's built for the electronic arts, new media art, and visual design communities, with the purpose of teaching the fundamentals of computer programming in a visual context, and to serve as the foundation for electronic sketchbooks. The language builds on the Java language but uses a simplified syntax and graphics programming model. Project schematic. The diagram shows the project schematic and how to connect the parts. Project demo. This part will demonstrate the project by using two cases. Case 1. Reading objects' distances and positions. The program reads first sweep and draws objects in green color, using their distances and positions. The angle is started from 0 degree and increases by 5 each step to 180 degree. The distance of object is started from 0 to 5 meters. The second sweep will draw the object again with a different color, which is blue, and the program will draw the average between the two sweeps in yellow color. Case 2. Detecting motions. After drawing the first and second sweeps, the program will compare the two reading values, and if there is any different it will draw an object with the last position by using red color. The red color indicates objects that have been moved. Conclusion. The main idea of the project is to stimulate radar system and use it within blind points, where the ability of vision is impossible. There is a trend to use this technology in different applications such as self-driving vehicle, self-parking and weather forecasting. There were several problems along with deploying the project. The first one, there was not enough time to expand the scope of the project to include the mobility. Second, there were a problem with ultrasonic that it does not read accurately. Third, there were a problem with the servo motor rotation that it does not cover the whole range. Thank you everyone for listening. Hope that was interesting and enjoyable.